Hi everyone, let's discuss today's lead code problem. So the lead code problem is 916 word substring. So you are given two arrays, words 1 and words 2. A string B is a subset of string A if every letter in B occur in A including multiplicity. So basic definition of subset is given to us that we already know. Let's suppose we have a word B and a word A and they consider B is considered to be the subset of A in case where every character of B is in A. I would write it is in A string. Okay. And if there are, let's suppose the B is given to us ELO and A string is given to us as ELOO, then in this case we can say ELO is a subset of ELOOO because every character is occurring the required number of times. But in the case ELOOOT and we are having ELOOOP, let's suppose, or what we can say ELLOT, and it would be ELLO. It would be occurring two times here and it is occurring one time here. And if we have, okay, this can work. So in this case, E is occurring one time, E is occurring one time. Okay. L is occurring two times. Is the minimum number of L's require here are two. So it is occurring four times. Okay. It works for me. O is occurring two times, but O is occurring only one time. So this is not a subset of ELLO is not a subset of ELLO because the count is not matching. Okay. So should this is what we should keep in mind when considering if B is a subset of A. So I have already told you the example. For example, VRR is a subset of warrior. As we can see, VRR is a subset of warrior. Can you validate it? Yeah, we can. W W is occurring. R is occurring two times. R is occurring. Minimum requirement of R is two. It is occurring three times. Good. Then we have warrior. Okay. Then we have world. W is occurring one time. W is occurring one time. Good. R is occurring two times. R is occurring one times. Okay. Sorry. The count is not matching because the minimum requirement of R is two. It is occurring only one time. Okay. We can say that. Now we are given the array of strings. Array of strings. That is basically word one string array. Word one that is having A and string array word 2 that is consisting of B. So a string A of word 1 is universal. Universal if for every string B in word 2, B is a subset of A. So what is this statement saying? Ki for every word in word 2, we are considering it V. Is that B? Ki for every B in word 2, we need to check if this is a subset of A. If this condition is good, or what we can say, this condition is validated, then what we can say is this A string is universal and we need to put it into a list of string and we need to return it for all the universal strings. Okay, so that is what the this statement is saying. A string A from word 1 is universal if for every string B in word 2, B is a subset of A. Okay. We need to return an array of universal strings. In word 1, you may return the answer in any order. Okay, let's think about it. कि मुझे I need to work for the string in the word 1. Let's see how can we find any pattern or anything we currently know about this. We are having this array, word 1, word 2. We are having E and let's see. For every word, I would pick it up Amazon. I would check for every string because these all are strings, not characters. Okay, don't be confused because these are simple single characters of the string. So these are basically strings. There can be more than one. So for each of the string, I need to check if B that is taken from word 2 is a subset of B is a subset of A that is from word 2. Now let's see the function which we have defined here. We'll check its implementation later, but let's see how can we check it. Ki E is occurring in Amazon? No. We can what we can do because we need to check this condition if B is a subset of A for every particular word. So it is failing for the first word, so we don't need to check. So we will move to the next word. We are having apple, and here we are having EO. Currently words are EO. Let's see. E is a subset of apple. Yeah, E is occurring. The minimum requirement of E was 1. It is occurring one time. I am happy. O is not occurring. That means this is also O is not a subset of apple. That means this is not universal. I'll move to the next A. I'm having Facebook. Good. I try to traverse for each of the string in word 2. I try to find E. Its occurrence is 1. I can check it is occurring one time. Good. O. I'm checking it. I'm looking for O. It is occurring one time. It is occurring two times. Good. For all the words in word 2, the word is a subset of A. Then the Facebook is a subset. If all the elements of word 2 are the subset of Facebook, then it is universal. We can add Facebook into our list. Okay. We move to the next. Google. Google. EO. Occurrence of E is 1. O is 2. Condition satisfied. Google is added into our list. Move to the next. Lead code. Good. EO E is occurring three times here. Minimum requirement 3. 1. Okay. O one time. Good. We also have lead code. So as you can see, I need to perform some analysis for each of the word in word 2, and we would be taking a individual A from word 1. So for each A, we need to check for all words of word 2. Easy. Now we would be having an outer loop. If we try to solve it in a brute force way, what we can do, we would be having a loop over for each string A in word 1. Okay, for each of the string in word 1A, and I need to check for each of the string in word 2 if B is a subset of A, then it is good. If B is not a subset of A, then we would be having a flag that would initially be true for all the cases. But whenever we encounter if it is not a subset of B is not a subset of A, flag will be false and we will break here. Okay. Now, after this B wala loop, we would be having a condition if flag is true for all the cases. That means that string is universal. I would add it into my answer. Answer dot add. So this will be my generic, what we can say, not generic. This would be my pseudocode for the algorithm we are trying to perform, which we can brute force. We can think in a brute force way. Okay. But for each of the string, how can we find the subset? So we need to validate for each a, if we are having is subset function in which we are having b and string a. I need to check I need to check one condition key for every string b it is occurring in a. Okay, so I need to count the frequency of each character in b. A, frequency of each char in a. Okay, so how can I find the frequency of each char in a? So I would be, because it is specified in the question कि it only have lowercase value. So it is specified in the question, it only consists of lowercase value. So we can easily maintain a array of size 26 int a chars equals to new int of 26, where a is represented by 0 and z is represented by 25th index. Now what we can do is traverse for each character in a dot to char array. I am the writing from the perspective of Java, and for each a chars I would not be having ach minus a, I would adding plus plus. Okay, I would be having frequency of each of the characters. Now I would check for each character in b chars. For each character in b, I need to check if it exists. If a chars of b char minus a is greater than 0, then good. This is what we need to verify कि कोई दिक्कत नहीं है, we can move to the next character. Okay, but before moving to the next character, this character count would be decreased so that we can validate this condition for the next characters or next same characters. Okay, but if there is a condition कि if there is it is greater than 0, then we can subtract it. But in the conditions, if it is smaller than 0, or what we can say in the else condition, if it is greater than 0, it is correct. If it is smaller than 0 or equals to 0, smaller than तो होगा नहीं, if it is equals to 0, we can have we can return false directly from here. Okay, otherwise we can return true. So this will be my brute force approach, in which I am just concerned about each of the characters in B and its occurring in A. That's why I need to maintain a frequency map of A so that I could count the characters of A, and whenever I traverse for each characters of B, I would check if it is present. If it is present, decrement its one frequency, check if the next occurring characters are matched. If there is the case, if a particular character count is smaller than equals to 0, we would directly be returning false. Otherwise, we would be returning true. Okay. So for this particular brute force algorithm, if I can see if word 1 is of size m and word 2 is of size n, and each word A is of size k, then we can see this algorithm requires time complexity of m into n into k. Okay, that is not good. And the space complexity of what we can say, where we are requiring any space to store the answer, we will not consider it. Uh, this 26 size, it is constant. We are not using any space. So space is constant. Okay. So this would be my brute force algorithm. You can code it out. Okay. We would be moving to the more optimized approach. Now let's look at the optimized version of the code. So in the previous version of the code, what we are doing in the brute force, so for each word B in words, we would be checking if it is a subset of the given word A. If all of them are subset, then we would add it into our list. Otherwise, if any of in any of the word we'll found key, if it is not the subset, we would be maintaining a flag, and if this flag become false, we would not add it, and we will break break for the entire list. Okay, so we need to optimize this particular approach. In such case, we don't need to check for each of the word. So we need to optimize this in terms of pre-processing words to array. So what we need to do in the optimized version of our code, we need to maintain a hash map containing the maximum occurrence of a particular element in all the strings in words to. So what I'm saying, let's suppose this is words to LO, EOO, ELLO, triple ELO. Okay. So each of the characters would be having some frequency. Ki L is occurring one time, O is occurring one time, L is occurring two times, three times. Okay. For each of the characters of a particular word, we would maintain a hash map. Key for LO at the 11th position, that is representing L, we have 1. For O, we only have one occurrence. So the maximum value of L till current situation would be 1. Okay. So we need to move to the next. Okay, we need to move to the next. We would be having E is at 4 because we are maintaining a hash table using an array of size 26 where 0 represent a character and 25 represent Z. So for O we have two frequency of O we would be maintaining in the hash map. So for each of the element we would be maintaining the maximum frequency. So when we traverse over all the strings, the maximum one among those strings we would take. Key, let's suppose 4 that is E. What's the maximum frequency? We have the maximum as 3. So we'll take 3. Okay. For 11, what is the maximum frequency? It is 2. We'll take 2. For 12, what is the maximum frequency? It is 1. We'll take 1. For 14, what's the maximum frequency? 1, 2, 1, 1. Okay, so we'll take the maximum frequency among all the words in the hash map. Okay, so how are we going to use it? So for each of the words in words 1, okay, for each of the words in words 1, we would be creating uh we would be creating what we can say a hash map. So create the hash table for each character for the string in words 2 that we have done. For each word in words 1, create hash table for it and check if the occurrence of each character in the hash table of A, that is the particular word, should be greater than the occurrence of each character in the words 2 table. That is, once we go over an example, it would be more clear. Suppose in the given example, we have LO and EO in our words too. So using those, we would be creating a hash table. So 4, 11, 14 at these position, we would be having one. Either all of them would be 0. Okay. Up to 25, we would be having this hash table. Now, for each of the words, let's suppose we would be checking key if Amazon is the special or the universal word. We would check key. We would create the hash map for this Amazon. So occurrence of all the characters would be specified. We will look at these particular words to hash table. Key occurrence of four, four, four is having zero because it is not mentioned here. Four would be having zero. Now, if it is having zero, that means it cannot be a special string or a special string because it does not contain the fourth element. We move to the next. For four, we have one. That's correct. We move to 11. 11, the minimum requirement is 1. That's correct. I have a minimum requirement for 14 as 1. Okay, 14 is missing. By we cannot move forward. Okay. Then I move to the next string. I require minimum requirement at the index 4 as 1. 1. 11. I don't have 11. Okay, you should also go. The next word. I require a minimum requirement of 1 for 4. Okay, I have that. For 11 I have minimum requirement of 1. I have that. For what we can say 14 I have a minimum requirement of 1. We have 2. That would satisfy my condition. Good. I have one string as Google. Okay. The other string lead code. The minimum requirement is 4. I have 3. That will work. I have a minimum requirement for 11 as 1. That will work. Minimum requirement of 14 is 1. 14 is, yeah, that's also satisfying the condition. We could return lead code. Okay, so this is how we gonna solve it. Key First of all, the initial step would be to create the hash table for all the words containing the maximum frequency for a particular character in all of the strings. Okay. Now for each of the word, if it satisfy the condition for a particular character in uh, words to hash table, then we would include it into our answer. Otherwise, we'll not include it. Okay. So this will be our algorithm, and if we try to see the solution, key I have previously written this particular solution. So what we can do, so initially we would be creating the hash table for words 2. So for all the words in verse 2, we'll create a frequency map for each of the word, and we can get the maximum of the particular character in the word, or what is the maximum frequency of a particular character in words 2. Okay, we have all characters here. After that, for each of the words in words 1, we would form the frequency map for this also, and we would check if at a particular situation, if this situation occur ki character frequency of the element in words 1 is less than the character frequency of a particular character in words 2, or the hash map of words 2, we can make our subset equals to false and we can break from it. Otherwise, if the subset if we don't get any exception here, we would add that particular word to my answer. Okay, now you can see one thing. We have optimized this solution. Key I just require a order of m. If we consider the size of words 2 as m, order of m traversal for traversing the words 2, and order of n traversal to traverse words 1. Okay, so total time complexity that would be required is order of m plus n. Okay, that's the maximum time complexity we can get. And the space complexity, when we think about it, is constant. How can it be constant? Yeah, we are using this space now. to maintain the character frequencies, but these are of constant size that does not depend upon the input of that does not depend on the input. So we can say कि the space complexity would be constant. Okay, order of. So this is my solution to what we can say the today's lead code problem, word subset. ठीक है? What's okay. This is the solution to the word subset. If you have any doubt, please ask in the comments. Or for more further videos, you can subscribe to the channel. And for next video, we will meet tomorrow. Bye bye.